Hello, this is Itsu. Okay, I got also a request for doing some power measurements, power out versus power in, which is kind of easy to do in this situation, but I don't think it has any value because we are way down because of the bucking coils. I have 10 ohm resistor here, and I measure with the yellow probe, so we can calculate, we can show the voltage across the 10 ohm resistor, which is 58 millivolts, meaning that the current through it is 5.8 milliamps. And if we calculate the power, then current times voltage, it will be something like, calculated it here, 3.24 microwatts. So it's a very low value, if I'm not mistaken. The input is something different. I measure with the voltage across the input with the blue probe, and I have the current probe measuring the current. At the moment we are at 20 volts peak to peak input, although it's throttled down, and 80 hertz, and these are the values. Yellow is the output voltage RMS across the 10 ohm resistor, and blue is the voltage, input voltage, and green is the input current, and we can see that they are both out of phase. I will put up the phase difference in a moment. I have only 4 positions to show, but it's about 82 degrees trailing. The current is trailing, so we have a inductive situation, which is correct. But it makes it hard to calculate the input power, so I have put up the math function, the red trace, blue times green, voltage times current. Blue is 4 volts RMS, and the current says 9 milliamps RMS, but this is the fixed value of my scope setting, and the real value is being set here at the controller, which is 100 milliamps per division. So the value here in green should be times 10, so we really have almost 100 milliamps RMS input, and 4 volts, which is calculated by the math function to 4.5 milliwatts, but also this has to be taken times 10, meaning we have 45 milliwatts input, if I calculate it right. And so we have a way disbalance between input and output, but that's to be expected in this bucking coil situation. I will put up now the phase difference between not from math, we want the blue, and we want it for the second channel. Okay, so we can see that the input phase difference between channel 2 and channel 4 is about 82 degrees inductive. Okay, hope this is of some value for some people. Thank you for watching. Okay, I forgot to change it, the frequency, to see how it dynamically changes when going up. I am now at 40 hertz, and we will increase now to 100 hertz. I did not put the frequency up because it's only 4 possible figure in boxes. We are now at 100 Hertz. This is 200 Hertz. Oops, sorry. Let me adjust some. I cannot change the current because it's controlled by this one, so I'll leave it there. Going up to 400 Hertz. Taking bigger steps now. 500. 1 kilohertz. So the input drops and the output also drops. .5 kilohertz. Well, you get the picture. Okay, thanks for watching.